I can.
Oh, okay, perfect. And I really think it's a really wonderful presentation, looking at the broader side of things, and having to talk about how ML in production is an abstract thing these days when it comes to data scientists and all of those things, especially in a growing economy. A growing talent hub like Nigeria, where people are not taught how to operationalize the code and even writing the pipelines and so on. But I just want us to have a discussion on that a lot, because this is actually a topic I stress on when it comes to building. Not just, it doesn't end your Google Colab instance. Neither does it end your Jupyter notebook or whatever IDE you use. It has to get to end users. And like you said, the end users are, of course, it could be engineers. It could even be another system. It could be another system you're integrating to, which is a really cool stuff when it comes to how ML powered systems can integrate with typical traditional software engineering systems. So I just noted out some points here, and really looking at Azure machine learning, for example. ML ops have actually become very, very how do I call it, very easier than before. Now you can typically just deploy like infrastructure as code, deploy your code infrastructure. Like, for example, Kubeflow. Kubeflow is an astonishing, amazing example of how to put ML pipeline in production, from data ingestion right to deploying to end users using Kubernetes and all of those things, which just gives that tale of how machine learning powered systems can integrate with typical software engineering strategies of putting apps and everything into production, which is quite cool. But I would love your thoughts on this, because putting machine learning powered solutions to production is one thing, but having to monitor them is really another crucial thing. And looking at, for example, the pandemic crisis we're currently in, no machine learning engineer would have expected this. To be very frank, no machine learning engineer would have expected it. So what are your thoughts? How would you say we can manage models in uncertain times that we're currently in? Because we can't predict things like this. We can't predict, and of course, models are often not good. I think George? I think that was a quote from George. Like, models are not expected to work as they should. They oftentimes don't work pretty much. But how do you think we can manage models, kind of monitor models better in production during uncertain times like this?
Okay, so usually I'm going to answer this question in a very, very satirical way. Even if without the COVID, how do you manage your models, literally? Because think about it. Management of deployed code, you gotta treat the model or the deployed code as something that you cannot lay your hands on. You got to treat it as something that has to work even while you are sleeping. So now let's replace COVID-19 with sleeping. So now you are sleeping. How do you manage your models? How do you monitor them? You can't literally just be here and be looking at your screen and be like, okay, it's working. I mean, that's like really, medieval. I mean, nobody even does that, right? So, that brings me to the software engineering way of managing stuff, of monitoring things, right? Or monitoring failures, right? Because what are you monitoring for? Most of the time, you're monitoring for negative engineering. You're monitoring for where things have gone wrong, right? So, so what do you do? What do you do literally is that there are tools like Sentry and Prometheus. If you're like, if you come from a machine learning, software engineering process, like in Python, you see things like, Prometheus. But the question is, what are you monitoring? Like, you know, I mentioned something in the first trigger where in the slide where I you know, maybe like there's a performance metrics drop, right? Because most of the time, that is why models return a score. You score something, you score something, you notice that it's all of a sudden, maybe you score. For me, for instance, now, I'm scoring an image or I'm classifying something and I want to return all my confidence score. So I keep logging my confidence score, for instance. All of a sudden, my confidence score start dropping to 40%, 40, 30, 20. That is not doing well. That is something that is a huge trigger for me, right? Okay, maybe it's okay. Maybe it's okay. But I want to be, for someone that is proactive, what if I want to study that over time? Maybe I could put a checks and balance that could tell me, that could say, you know, I want to take the average performance score that I have done for the past 24 hours. I want to take an average of them. What if you decide to write a very, very tiny script that checks the average scoring that you've done for the past let me say 1 week, and see, okay, this is a range. If this is not giving us over 60%, this is bad, right? So, you know, performance scoring and monitoring, I'm talking about monitoring by performance now. It's up to your company, it's up to you people, it's up to your like your industry on what matters to you. Someone could see a 60% confidence on the score and be like, this is good. It's not bad, it's okay. But someone can be like, oh man, that's critical. I mean, for an industry like finance, right? If I know that any decimal of difference, any margin of difference is a problem. So how do you manage something like that? You know, so what I think is that monitoring is a lot of things. For instance, data was supposed to be ingested. It didn't ingest. You're monitoring that. Machine learning machine learning model was supposed to, the throughput. Because of course, it's not just about the fact that it's predicting. How long does it take you to make a prediction? Like, the time of prediction is also very big important. I mean, it's something that you have to calculate. I mean, if you have 1 million users that depends on that prediction or that model to function, and then it takes 40 seconds for one person to get a prediction back, I mean, that is not working. So if you could be, you could start monitoring time of prediction. You could say, oh man, this is a lot. I mean, you think about it. Does that mean that we can satisfy 100 million users today? See, most people don't even know that there's a lot of, I was studying what Instagram is doing, how Instagram is using, very good machine learning process to serve people, content, right? And now imagine that Instagram has that model running and it's taking a lot of time to figure out what to serve you. So it means that you might not get a content at all. It might take time trying to give you what it depends. So, you can monitor that. You can be like, yo, this is taking a lot of time. So if this time drops to this or increases to this, let us know. This is something you have to monitor. So it's more like, so you gotta be proactive. For me, what I normally do is that I make a list of the things I don't want to happen. Like red flags, like this is a red flag. If this happens, red flag. If this happens, red flag. So what I normally do is that I don't wait for that to happen, right? So I move my pin more. I move my pin back, and I'm like, if you're getting to this yellow angle, please let me know. It means that you're tilted to a wrong place, right? So the monitoring from data systems. So let's assume that you are ingesting 1 terabyte of data, right? And okay, you're ingesting 1 terabyte of data, and you can't be online and or watching your data system to ingest. 1 terabyte could take 1 week to ingest, right? But you need to be proactive to know that sometimes, how do you know when the transforms that you wrote, they are not working? Let's assume that when the data comes in, you have to, find an average. The classical example would be you are trying to load a data that came from a production system. Let's assume that, and let me think about how MTN would be storing something like star 737. I don't have a limit to star 737 a day. If a user can use star 737 service 10,000 times in a day, but you don't store that data for analytics 10,000 times. So you probably need to find the average time or the sum of not time that a user used star 737 service in a day, in a week, in a month, in a year. So you want to know what they used it for. But you don't also, this is a logged data. Now, you have to move this data from somewhere to somewhere. And you've written transforms that find us, different service. If it was a bank transfer, store it here. If it was a credit recharge, store it here. Check for account balance, store it here. But it's same user, right? So, this is a lot of transform that you've written now. Yeah. But you would also need to know when the data movement is not working. So you probably for me, my first monitoring would be to check for empty columns. If something is returning, and I decide to check at intervals, run queries at intervals. If for instance, that is why you have things like, for data engineering, you have things like Airflow, Celery, to be able to, at times run whatever. See, it's code. You have to be creative. It's up to you. You can decide to even go and check if your database is increasing. Anything you decide to do to monitor is fine, right? It's up to you. You can monitor in a naive way. You can monitor in a big way. So I think machine learning monitoring comes down to you knowing what you don't want to happen, and then position yourself in any way you want to position yourself to take care of them or to know that they are happening. Your reaction to that is not entirely up to you, but at least you know that this is happening and there's a red flag. So I think.
Yeah, I absolutely think. But of course, just to round that off, it's just more of monitoring the entire pipeline rather than just the production of things. Which makes. Sense. So, but it also leads me to another point when it comes to monitoring. People often neglect the absolutely crucial step of A/B testing. Of course you try a new feature and you want to monitor how it does, and but the thing with ML ops is a model is at its best before production. That's like so the moment you put the model to production, it begins to drift and begins to degrade and all of those becomes stale and all of those things. But having to do this A/B testing, people just think it's just for decision scientists to just work with the A/B testing. But I think it's absolutely crucial that companies look at the idea of A/B testing as a thing. You put your feature into production, or you put your product into production. How do you expect that you get the feedback to use and make data-driven decisions to improve that product itself? So, what's your take briefly on A/B testing for companies?
You see, A/B testing is a skill that is as old as the Assassin's Creed, right? I can say, there's a reason why you have to. Some people, for instance, Facebook is notorious for this. Facebook is very notorious for running like 200 models in parallel, testing something, right? You don't even know. Like, for instance, think about it. Even in software engineering, in fact, the beautiful thing is that even as, not trivial, but you wouldn't know that there are companies that do A/B testing down to web UIs. So what they do is that they kind of like section users based on geolocation and IP. So if you're coming from this IP address, serve them this. they're coming from this IP address, save them this website. If they're coming, so they're trying to find out which one people interact with. In fact, in the same geolocation, they will scramble it. So you don't even know that you are getting a different web page from someone else. Right? So why do they do these things? They do it because they want to get the bulletproof experience. They want to find out that this is what works best for us. Now, let me tell you, the truth is that A/B tests are very expensive. I mean, you got to also know that one of the things that people don't highlight is that if you want to do ML ops in a stellar way, it's an expensive procedure. One is that a lot of things can go wrong. It is technique sensitive. I'm just going to be very honest with you, why most people don't want to do that. Imagine that you have spent, your machine learning system or your model has to run in a different server instance on AWS, and it's going to cost you money while you're running it. But or maybe you don't have the skill to probably use Docker containers to split these things, right? Yeah. And you don't have the engineering to think that far, or you probably don't know how to run it in low cost. And it's taking you like $10 every day to run something. And then you have to do, and you want to do A/B testing. It's good, but I think my take on that is that the good part is that you usually end up knowing what works best. But the second part is that you also have to understand that it introduces a level of complexity that you should take care of. And of course it's more about, you see, there is something that I don't see a lot in machine learning, systems around here in Nigeria, or in Africa, where I've seen, people don't like documenting their process. So there is no clear-cut technical requirements or projected technical involvement this may take. No cost evaluation. People just think it's all about pandas and Jupyter notebooks. It's not even about databases. It's not even about, everything should be accounted for. Everything. So that when you're about to go into A/B testing, you are sure that you can literally just triage. You can just let's do it this way, or 3 or 4 or 5. And you can project that this can cost you this can cost you this manpower. If we are trying to do A/B testing for so number of people, this is the benchmark. This is what we need to do. If people are increasing, we can test for them. So I'm saying that A/B tests usually don't work so well around here because people just think that A/B testing is just like running the model in 2 places. No, it's not. If you're doing it, just know that that's double engineering. That's double of what you're doing. Yeah. That's double complexity. So yeah, but it works good. Apparently, I love it. I love it. If you have the resource, go for it. Yeah.
Oh, okay, awesome. And I think will, of course, lead me to a crucial point. And one thing I've noticed when it comes to doing machine learning in Africa, generally we are becoming Africa, Nigeria, becoming a talent hub of data engineers, machine learning scientists. And one thing I typically see people don't take into consideration while it's talking about the algorithmic effects of not just putting a machine learning model into production, but the fairness, of course, the ethics, all of those biases, and not just putting a machine learning model into production, but as well as collecting the data. And that's the crucial point we are in. We don't have that, the quality data to use to make data-driven decisions. And of course, going forward, in the next couple of years, you start seeing systems whereby we start gathering data needed for Africans by Africans. And if we don't talk about this early enough, it's going to be a huge problem. You talk about algorithmic biases, but then it's in the data that's the bias, because it's the data, of course, that interacts with the real world. So, and biases come from the real world. So, what are your thoughts on how we can mitigate bias, not just in data collection, but in production?
So for me, I was talk about bias. What makes it so scary is that because you don't have so much people talking about it, and I can tell you why you don't have so much people talking about it. It's because it's always in stealth mode, right? You're collecting data, you can see this happen several times, especially if people train a machine learning model with a data that tags someone. That's why people will tell you, don't train something in a way that it tags a class of people. It has to be on neutral data, right? For instance, you are Steven and I'm Steven. If anybody trains a model with anything that tags Stevens as people that wear glasses and they do machine learning and maybe something weird stuff again. And the next thing is that if there's a Steven that is a priest, is tagged as a mission, it becomes stupid bias because you were thinking that it makes sense while you were doing it, because apparently the task looked like you were trying to learn about people with a particular characteristics, right? Now, see the trick here. It comes, Andrew Trask, it's a huge hero, like Aurélien Girard. Like, these are the people that I have looked at whenever I want to, like, when I wanted to scale things up in machine learning. Trask did the work in federated machine learning. The question was, instead of bringing the data to the model, why not we bring the model to the data? And you don't know what you learn. So the model goes to the data, learns what it has to learn, and then comes back without knowing what it learned. Because that way, you have less bias in models. Because it happens. If in the future, there was a funny thing that was happening on the internet. It was funny, but it's not funny. So the image recognition device, a white person was holding something, it recognized that banana, all right? But when a black person was holding the same thing, it was a gun, And it might appear it might think that it's like a funny stuff, right? But this is exactly what is going to happen. If you have someone that was trying to train a model on detecting when someone is holding a gun, and you have an imbalanced device or imbalanced data that is practically looking at the skin color as a metric, not the gun, because the gun is the concept here, not who is holding it, right? The gun, and if you can find a way to, it's a human being. It should be a human being, not a black person with a gun. Once the data starts treating it as a black person with a gun and a white person with a gun, first of all, you've introduced two classes. And for whatever reason, those two classes are not balanced. That are not balanced, that they are superimposing. Not just balanced that they are the same. Balanced in a way that they are you've trained it with all types of skin color, Latino, everything. Because you've brought this class and you've brought large bias. That's because the thing is, you might be thinking that you are safe because now, you see the problem with learning bias is that it's so weird that it can spiral to anything. So if you've left skin color, you didn't even know that it was also looking at the nose orientation. That you have to. So if you might be white skinned, but your nose is not pointed, it's not a banana you are holding. You have a gun, right? And you might find out that. So the thing for me about bias is that I think it's also part of. So I think machine learning engineers should study up on ethics, and also, they shouldn't just jump on data. It takes a lot of time to look at data and look at what can tag someone wrongly here, or what can classify things wrongly here. If it's in finance, bias is a huge thing in finance. If you see it happen all the time, I can tell you, if there's any system that you find in finance that gives loans based on machine learning analytics, that system is almost always biased. And they know it, but they can't do anything about it because it's already flawed from design. I tried something. I'm not going to call a name, but my friend and I, we used there's this loan platform. We didn't need the money, but we were arguing this bias. So we used the same detail, the same device. No, we didn't use the same device. So he was using an iPhone and I was using a Huawei, right?
Yeah.
And we used the same thing, education, everything. Guess what? Because the system picks up the device the person is holding, and the system approved his loan based on the iPhone. And didn't give me a loan based on the Huawei. You know what? This is real. I can tell you that at some point, when I got insight on the system's data that they are using, I could tell you this was where it came from. I saw that the system was recording, people's phone means that so it means that you've put someone on a class because they have an iPhone. That's a very weird bias, right? And the funny thing is that it's not even correct. Because what makes bias a bias is that in human day-to-day life, that does not hold water, because there are people that have iPhones that are not loan worthy. Mm-hmm. And I was so surprised because I was like, yo, I'm even more loan worthy than that guy. Like, I told him, yo, bro, I'm more loan worthy than you, but you got the loan. So this is not even working. This does not work, because if it can affect me, that means what about someone that has a techno, but probably is more loan worthy? So I think bias is happening like every single day in machine learning. So it's one of the ways I think people should counter this is the data is the problem. When you are choosing the metrics of judgment, let it not be from emotion. Is this statistically balanced? Like, do you really think that this statistically makes sense for you to use as a metric? Does it make sense for you to use heights? And it also depends on what you're trying to solve. Imagine you're trying to solve crime and you're classifying people based on height. So somehow your data is now pointing that short people are less prone to crime, but tall people can commit crime. And you don't have statistics, well-balanced statistics guiding this. If you ever do that, that's a very huge crime. I think, you know what I think? Sometime in the future that it should be crime against machine learning community. Like, once you do it.
A very regulated community.
Yeah. Mm-hmm. Yeah, like if you just do this, and if this data does this to people, you should just go to jail. I think that should work. I mean, that's my input on that. Yeah.
Absolutely, because a lot of things that happen with machine learning having to do with the real world comes with the bias, and of course, real world bias comes in unconscious and conscious format.
It's bias.
You're talking about giving a loan based on iPhone. That's definitely conscious reporting bias there. And that should be something.
It's human.
Yeah, that should be something that, of course, people get to take accountability and optimal accountability for, because we are going to be seeing situations whereby less privileged people are going to be seeking for loan, and they're not going to be getting it because, hey, human bias. And
because of your phone.
Can you imagine? I definitely know a lot of people who can repay loans, and damn, they're just using what type of, and can you imagine this sort of metrics? But generally, I just feel going forward, especially in the case of the example whereby you gave for the criminal, where the black person holds a gun, and sensitive data like that, kind of masking, coercing very, very sensitive data will help us going forward. Ethics behind that, not just pushing and gathering data, building models and pushing them to production, but making sure that we are well conscious of the governance behind the data, as well as the ethics behind it. Because the thing is, they have machine learning engineers, data engineers need a special master class on data governance. And that's a key thing. Because, for example, there are some specific people that need restricted access to data. Not just everyone. You don't give everyone in the broad spectrum of your team access to data, for example. Some people have to have their data masked from other people. And depending on the context of the problem, like you said, bias can come in every form. Even in a particular problem, there could be various sets of biases. And how can we make sure that we're well aware of these biases and we are doing things to mitigate them, which I think is absolutely fine. So I think we've had a lot of conversation today. It is really exciting.
Thank you. This is fun.
And I think what we have to do now is just to wait for the podcast time. The time for the podcast, of course, we'll probably have a more comprehensive conversation.
Sure, I'll be looking forward to that.
And this should go up by evening time. So just to thank the viewers now. Thank you, viewers, for attending the session today. And see you next time. Yeah. All right.
Sure. Bye,
Stephen. Yeah.
Bye.
Yeah.
Bye-bye.